This video has been translated to English and edited by Eric W9MDB. Hello everyone, this is Chris, SQ8ERS. Today, my workshop received a transistor amplifier, the Expert SPE 1.5K FA, Ldmos transistor amplifier. This is a newer version of the earlier 1K FS amplifier which used MRF transistors. After checking the voltages and measuring the MOSFET, for the first time it turns out that the transistor is damaged. And unfortunately, the repair is not cheap. The transistor is quite expensive. And unfortunately, if you want to fix it, you have to replace the transistor. Apart from that, all other functions of the amplifier are functional. You can turn it on, turn it off, and so on. I have already disassembled the amplifier to diagnose what's going on and why it does not output power. As I said, it turned out that the Ldmos transistor was damaged. So the owner of this amplifier ordered a new Ldmos from the United States. I will show you in this video how to replace it. And this needs to be done carefully. Replacing the transistor, I will let you know it is the MRF 1K80N transistor. The maximum power is 1.8 kW from this transistor. So internally it is a double Ldmos. Maybe before I start disassembling this amplifier, I can show you a little closer what it looks like inside. As you can see, the amplifier is very nicely and solidly made. Here in the front part, we have the bandpass filter. It is very nicely designed. Some of the coils are wound with silver wire. Some are wound on toroid cores. Moving here in this direction, we have an antenna box. And here we have the antenna switching network in the back. 4 antennas can be connected here, and 2 coax inputs. The 2 separate inputs allow for 2 radios, radio 1 and radio 2, and it's a nice solution if someone works in contests. This is the PA stage of the amplifier. The LC relays are mounted underneath. This is our damaged Ldmos here. I've loosened things up a bit, but the transistor is not screwed on. The transistor is soldered in place to a heatsink copper bar. The amplifier upside down here, as you can see in this part, it is built with a heatsink Here are some of the RF filters are located. And here's the power supply, a 53 volt. The power supply is quite large because it covers practically the entire amplifier. This is a switching power supply, not a transformer one. As you can see, the power supply is also quite large. With the full power of 1.5 kW, it should give around 40 amps, so this is actually quite a large current for a power supply. And here we see a whole board of electronics that controls this amplifier. Some of the other things that can be done here are the fans. This one definitely needs to be replaced. It's the main one, and it's loud. This fan also needs to be replaced at the same time. And I will replace this one too. Also, 2 new fans are here ready for replacement. The PA board is already partially dismantled, basically unscrewed. For the second part, you just need to remove the board from here and desolder the transistor so you can make room for the new one. Yes, one board is dismantled. There is some paste here. I had to be careful. There is a thermistor that checks the transistor's temperature, which is located here. And then, of course, it controls the airflow that cools the amp. And there are transistors here too. I will replace the paste later and put a new one in. I'll clean it and screw it back on. I won't unsolder these wires at this stage because I don't want to disturb all of these things. I can unsolder this board from the transistor. You need to perform some tinning here. I'm going to apply a little bit of flux. I have special equipment prepared for this. Well, you probably can't do this with an ordinary soldering iron. I mean, I will try to unsolder a little at a time. Here you go. The heatsink copper plate has been removed with the old chip. It is not screwed. You need to do the same process to solder it back to install a new transistor, and later reassemble the amplifier. In the so-called meantime, I moved here to the next stage, and I'm heating the copper plate on a hot plate. I have to desolder this transistor somehow. It won't be easy. So I have to slowly heat up the entire plate, and we'll see how it goes. As you can see, the transistor has already fallen off. I will clean this surface now. Apply new solder along with the new transistor. As you can see, the old transistor is already desoldered from the plate. The copper bar here has been cleaned of the old flux and solder. Now I have to heat it gently. And I will solder in the new transistor. Proper placement of the new transistor is important. I'm going to place the transistor here and don't want to move it. Okay, the transistor is already soldered onto the bar, so I will slowly assemble the amplifier next. The plate has cooled down. I cleaned it, of course. Here is the aluminum heatsink underneath, which too has been cleaned. The old paste has been removed. The surface is spotlessly clean. So now I'm going to put some new paste on here. Okay, the paste is being applied. very thin layer. You don't need a lot of paste. All I have left here is clean up the solder pads where the transistor will be soldered. Here on this one I have cleaned the pads, and I will clean the other board so that I can easily solder the new Ldmos. To the board lands. Okay, the paste is applied. I can move to the next step of assembly, installing the board with the transistor. Both boards have been screwed into place. Now all I have to do is solder the input wires. Reconnect the wires, connect them here, and then I'll start soldering in the transistor. The wires have been soldered. Next, an important detail. It is very hard to see here. This is the thermistor temperature sensor. I will put a drop of thermal paste under the heat sink of the thermistor. so that the temperature is measured properly by the sensor. The next element here will be soldering the transistor, the choke, and check if the amp works later, of course. Before starting the amplifier, you need to do something. We'll be setting up the bias, the quiescent current needed for the transistor. Okay, I managed to solder the transistor. Here I will check whether there is any short circuits and make sure there's no solder blobs anywhere touching anything. So I still have to slowly check before I connect this amplifier to the power supply. Well, as you can see, you need to provide some heat to solder it. A lot of flux is used, and unfortunately I had to use a slightly larger soldering iron. Yes, but unfortunately it cannot be done with a transformer soldering iron. It has to be a resistive soldering iron. Okay, just a quick check. I'll clean up some of the flux from these lands. I will see that it all looks good and prepare for turning on this amplifier and setting the quiescent current. Okay, now comes to the next stage of the amplifier repair. The power amplifier is assembled. The amplifier is already partially assembled and is missing only housings. Transistor soldered in. Now you need to set the quiescent current of this transistor, in other words, bias. To do this, we need to use, and we don't need to use any special tools. We can use the display here. It is the amplifier. There is a current measurement here. I'm going to show you how to do it. You need to turn on the amplifier. I have a special button connected to the PTT input, which I will use to apply a PTT to the amp, because we will have to put the amplifier in transmit. Here it shows that we have input number 1 and I have input number 1, this button connected. Antenna number 1, band 20 meters. And another important thing here is just setting this one, output power. There are 3 levels here. You can set 3 levels on this amplifier. The lowest level is that low, i.e. the amplifier is in low mode, operates at maximum power about 500 watts. We switch to middle mode. The amplifier operates here with a power of approximately 900 to 1000 watts. And the max mode. The amplifier operates at full power of approximately 1.5 kW. And we can also take a look at amplifier here. Of course, the amplifier must be in operate. mode that is in this mode, ready to work, ready to transmit. And we see these voltages. By the way, we have full voltage on the 53 volt transistor here. We have in the mid mode, we have 45.8 volts, and in the low mode we have 36.7 volts. That's exactly how it makes the power adjustments. Power output levels are controlled by the power supply. Via the voltage being applied to the transistor. This works most effectively. So let's continue. We set the quiescent current. We set the out max. We have set in the operate mode. I am currently displaying the outgoing power and current. The current that will be drawn here is enough in the PTT mode. Press the button. Here is the regulation current or quiescent current. Current potentiometer set all the way counterclockwise, lowest value. Now I press PTT transmit. And it shows 0.7 amps. And I turn the potentiometer on the PA board to adjust the current. It should be set at about 1 amp. This is how the current should be set correctly. And I leave it there to check if everything is correct. I will connect the amplifier to a radio and check the individual power in individual operating modes. If this power is too low, maybe a little later, I can turn up the bias. This current here cannot exceed 1.4 amps. So that's all there is to it about setting up the quiescent current. The amplifier is connected to a dummy load and connected to the radio. Turn on the amplifier and radio. We have 20 meter band. Antenna number 1B to bypass the ATU. Kenwood will set it to low here for now. This amplifier operating range, temperature 21 degrees, i.e. the temperature is displayed correctly. Now we'll try to give some of the first testing. I'm setting up the amplifier and the radio with an output of about 5 watts for SSB phone. We turn the amplifier to operate mode. The fans will turn on. Control power 5 watts. And we check if it works. Hola, hola, 1, 2, 3, 4. It looks like 1, 2, 1, 2, 3, 4. Hola. I'll add a little more RF power. Hola, hola, hola. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. One, two, three, four. 1, 2, 3, 4, and you can see the power output is correct here. I'll change the power here to mid, to the 1000 watt showing up here. 1, 2, 3, 4. 1, 2, 3, 4. You need to add a little more control power. Now it's about 15 watts working. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. One, two, three, four. 1, 2, 3, 4. Here I also increase the control power 2 kilowatts. 1, 2, 1, 2. One, two, three. 1, 2, 3. 1, 2, 3. 4, 3, 2, 1. 4. 1, 2, 3, 4. 1, 2, 3, 4. Test 1, 2. 3, 4. Test. And I think you can safely leave it like that. I will adjust the quiescent current slightly later. Here you can see that the amplifier is working properly. So I still have only to replace the bad fans. We have the power supply. I have one housing before we put the top one on, and replacing the 2 fans that make noise. I also have a few fans. These fans are very dusty. And the number one has the biggest airflow. Simply needs to be replaced because they are loud. The remaining two fans are here, will be replaced. They cool the power supply. And these two on this side are cooling the power amplifier side. Just a note here, this is looking from the bottom of the amplifier. Okay, the amplifier is screwed together. Checked, ready for work. A few more words to summarize. As for the expert company, it has been on the market for many years. Even now has won many fans for this brand. Lots of devices surely sold all over the world. These amplifiers are not the cheapest. We have to take this into account. Personally, I also have an older version of this amplifier, the 1K which uses the MRF transistors, and for many who use this amplifier, nothing has ever happened. Unfortunately, these new devices, the Ldmos, are made on transistor Ldmos type, so my opinion, these transistors are a bit unpredictable. When purchasing such a device, you must take into account that something may happen if you damage a transistor in the amp. And the repair is not going to be cheap. The owner, even though he used it rather occasionally, for some short conversations, possibly sometimes to call DX, he didn't actually overwork this amplifier. Unfortunately, the transistor simply couldn't handle it and it got damaged. When deciding to replace transistors at all, you need to use the original transistor model. All fake non-OEM devices and so on are out of the question here because they are unlikely to work. So I'm glad that it was repaired efficiently, and I think the owner will also be satisfied. Thank you for all your attention. 7.3s and good DX, SQ8 ERS.